Today we are solving LeetCode Problem 1161, maximum level sum of a binary tree. We are given the root of a binary tree. The root is at level 1, its children are at level 2, and this continues level by level. Our goal is to find which level has the maximum sum of node values. If multiple levels have the same maximum sum, we must return the smallest level number. Key observation. This problem is all about processing the tree level by level. Whenever we hear levels in a tree, sum at each level, the best approach that should come to mind is breadth-first search, also known as level order traversal. Intuition. Tree levels naturally suggest BFS. Compute sum level by level. Track the maximum sum and its level index. Approach. Use a queue for level order traversal. Traverse the tree one level at a time. Compute the sum of each level. Track the maximum sum and corresponding level. Return the smallest level with the maximum sum. Let's understand this problem using example 1. Example 1 input. Root equals 1, 7, 0, 7, minus 8, null, null. This represents a binary tree. Step 1. Identify levels. We process the tree level by level. Level 1. Nodes. 1. Sum equals 1. Level 2. Nodes. 7, 0. Sum equals 7 plus 0 is equal to 7. Level 3. Nodes. 7, minus 8. Sum equals 7 plus, minus 8, equals minus 1. Step 2. Compare level sums. Level sum 11273-1. The maximum sum is 7, which occurs at level 2. So the output is 2. Why BFS works here? Because we process nodes level by level, we can compute each level's sum easily. Compare it immediately with the maximum seen so far. Track the smallest level in case of ties. Example 2. Quick walkthrough. Example 2 input. Root equals 989, null, 10250, 98693, minus 89,388, null, 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 minus 32,127. Level-wise breakdown. Level 1. Nodes. 989. Sum equals 989. Level 2. Nodes. 10,250. Sum equals 10,250. Level 3. Nodes. 98693. Minus 89,388. Sum equals 9,305. Level 4. Nodes. -32127. Sum equals minus 32,127. Maximum level sum. The highest sum is 10,250, which occurs at level 2. So the output is 2. Final conclusion. In both examples, we traverse the tree level by level using BFS, calculate each level's sum, and keep track of the level with the highest total. If multiple levels have the same sum, we return the smallest level number. That's why BFS is the perfect approach for this problem. Step-by-step explanation. Step 1. Use a queue for BFS. We start by using a queue and push the root node into it. This queue will help us process nodes one level at a time. Step 2. Track level and maximum sum. We maintain a variable to track the current level, a variable to store the maximum level sum found so far, another variable to store the level number where that maximum sum occurs. Initially, maximum sum is set to a very small number. Answer level is set to 1. Step 3. Process each level. While the queue is not empty, get the number of nodes currently in the queue. This tells us how many nodes are in this level. Initialize a variable current level sum to 0. Process all nodes in this level. Add their values to current level sum. Push their left and right children into the queue, if they exist. Step 4. Update maximum sum. After finishing one level, compare current level sum with maximum sum. If it is greater, update maximum sum. Update the answer level to the current level number. Because we only update when the sum is strictly greater, the smallest level is automatically preserved in case of ties. Step 5. Return the answer. Once all levels are processed, we return the level that had the maximum sum. Today we are solving LeetCode Problem 1161, maximum level sum of a binary tree. We are given the root of a binary tree. Each level of the tree has a sum, and our task is to find the smallest level number whose sum is the maximum. Step 1. Core idea. The key idea is very simple. Traverse the tree and keep track of the sum of node values at each level. Once all level sums are calculated, we just return the level with the highest sum. Step 2. Data structure choice. We use a hash map, dictionary, where the key is the level number. The value is the total sum of nodes at that level. This allows us to accumulate values efficiently. Step 3. Tree traversal. We use depth-first search, DFS. For each node, add its value to the current level sum. Recursively visit the left child at level +1, the right child at level +1. Even though this is DFS, we still correctly track level-wise sums. Step 4. Finding the answer. After traversal, all level sums are stored in the dictionary. We find the level with the maximum sum. If multiple levels have the same sum, Python automatically returns the smallest level as required by the problem. Step 5. Return result. Finally, we return that level number. This gives us the correct answer. Let's run this with the example tree. Everything looks good. Submitting the solution. And accepted. All test cases passed successfully. That's how you solve maximum level sum of a binary tree efficiently using DFS and level tracking. If this explanation helped you, like the video. Subscribe for more LeetCode walkthroughs. Comment if you want a BFS version next. See you in the next problem.